calling video range.
A space projectile has just left the planet Earth.
What can we do? Our only chance is to flash between them before they meet.
Hello everybody, my name is Bob, and this is Space Colonization with Bob number 2, and also with Mango. You may see Mango put in an appearance here because he's right here. Today we're going to talk about lunar resources, Mango. Lunar resources. What resources and assets of other sorts does the moon have, and what doesn't it have? The first most important asset of the moon is location. Location, location, location. It is the closest celestial body by far. It is, compared to going anywhere else except maybe some passing asteroid or something, definitely closer and easier to get to. That's asset number 1. Asset number 2 is gravity. We don't think of it that way very often, but gravity is an extremely useful thing. Something that we don't have too much of in 0G. Or actually, we do have gravity, just that we're in free fall in 0G, and so we don't have the beneficial effects of gravity. Chemical processes on the Earth, when the chemist goes to make a new chemical, or when when a industrialist goes to smelt a metal or something, he uses gravity. And there are a lot of things that are hard to do without gravity, or that you'd have to substitute for gravity in some way. It's either a centrifugal force or something else. Totally aside from the fact that human beings need gravity. Gravity is very useful for many chemical processes that we might like to do. Location and gravity are 2 very important assets that the moon has. Another asset that the moon has is, although it does have a gravity well, it's not that formidable compared to, say, having to launch a rocket off the surface of Mars. Getting something off the surface of the moon is pretty reasonable. Keto. Mango, mango, mango. You gonna say hello to the people of the YouTubes? Keto. So those are the non-mineral, non-chemical assets that the moon has. Mango. Say hello to the people of the YouTubes. Yes. Mango loves the people of the YouTubes. Okay, let's talk about the mineral assets of the moon. We're not talking about how you're going to turn those mineral assets into something usable. We're just to talk about just basically what's there, physically what's there. How we're going to get the raw materials into some kind of finished form, that's a topic for a whole other video. But simply look at what's there. First of all, what resources on the moon can we obtain without having to jump through a whole bunch of hoops, without having to that are very easily readily obtainable on the moon without a whole lot of trouble. First one is oxygen. Oxygen should be able to be extracted from the lunar regolith with relatively little trouble. My understanding is simply you just heat it up sufficiently, and the oxygen will be driven off, and you just collect it. So oxygen, that would be the first thing that would be very easy to get on the moon. Something that would be useful for instance, exporting to low Earth orbit for spacecraft to space stations. That's the largest single component of lunar regolith is oxygen. Another thing that would be pretty easy to get is iron. Pretty much you just drive a really heavy, big, powerful industrial magnet over the surface of the moon, and there are all kinds of little tiny fragments of iron from meteorites and such that'll simply just stick to the magnet, and then you just take that magnetic material and smelt it, and you've got iron. Iron, not steel, because to make steel you need carbon, and there's no carbon on the moon to speak of, or not that we've seen thus far. So cast iron is probably going to be a real popular material on the moon. Steel, you have to have carbon, which means you have to have a source of carbon, which we don't have one on a source of carbon on the moon yet. So oxygen, iron, also building materials and sheltering materials. If you get people on the moon, you're going to need to have them covered up somehow, because one, there's more ambient radiation just in general on the moon, and two, if you have solar storms, and you have really lethal levels of radiation, and you need people and equipment and things to be sheltered from that. Also, if you need to radiate heat from somewhere, that's kind of difficult to do on the lunar surface during the day, unless you have a sheltered place that's not exposed to the sun but is exposed to space. So shelters made of the lunar, just basic lunar regolith, that's going to be an important thing. And you can also use things like 3D printers to print out blocks of material out of the regolith to build structures with. Oxygen, iron, and shelter are three things that are fairly uncomplicated to get on the moon. There are other materials that are more complicated. Aluminum. There's a lot of aluminum on the moon. Problem is that, well, there's two problems. One problem is we are used to using relatively concentrated ores of aluminum on Earth. Those ores don't exist on the moon. There are other materials from which very useful amounts of aluminium. There are plenty of resources on the moon from which we can extract aluminium. Problem is that all of our industrial techniques for making aluminum from ores involve materials that are available on the Earth and not so much on the moon. Smelting aluminum the way we do it on the Earth requires, fluorine and things that we just probably won't have on the moon unless we bring them up. And bringing things up to the moon in bulk is something from the Earth is something we probably want to avoid because it's expensive. So we need to find new ways of making aluminum using lunar materials. Another item that's fairly common, should be fairly easy to obtain in theory on the moon, is titanium. There's lots of titanium on the moon. Again, the difficulties of turning those rocks into actual usable titanium, that's something for some fairly hardcore experts to work on, because right now it's not clear exactly how that's going to work. But the resources are there, assuming that we can find a way to transform them into usable materials. There's also calcium on the moon. There's also magnesium on the moon. Aside from the uses of those materials in other ways, calcium, aluminum, and magnesium make excellent solid rockets because they all oxidize very vigorously. So if you want to have solid rockets or metal hybrid rockets of some sort, those materials will be useful. I think of what else is on there. Those are probably the most common ones. What does the moon not have? Well, there's maybe some hydrogen on at the poles. Aside from that, hydrogen is scarce as hen's teeth, and that is important because people like to drink water and people like to use water for all kinds of purposes. And the only place that we know of to get the hydrogen for that water is at the poles. What form does that hydrogen take, and is it even there for sure? We won't know until we actually send some robotic lander there to take a look at what we found, and what form it takes, and so on. The fact that we haven't done this yet is just sort of mind-boggling to me, because water is one of the most critical materials we will need for space colonization, and which in fact we need in space, like the International Space Station. They recycle their water pretty vigorously, but I mean, I'm sure they still need imports of water occasionally. And also, you can use water to make rocket fuel, hydrogen and oxygen. So water is a biggie, and why it is that we have not gone to investigate these hydrogen areas at the poles is quite beyond me. The moon, as far as we know, has no appreciable amounts of nitrogen, carbon, microscopic amounts of helium, no hydrogen except for maybe at the poles. All the lighter elements pretty much are scarce as hen's teeth on the moon. So if we're going to actually colonize the moon, that's going to have to be addressed. One potential way of ameliorating this is we don't know what kind of subsurface deposits there are on the moon. For instance, we could do a process similar to what they do with natural gas drilling here on Earth, which is we drill down, fracture the rock with either explosives, or you could even use nuclear explosives, and see what comes up the pipe. And we don't know exactly what may be down there. There could be, just like on the Earth, there's in a natural gas formation, you have permeable rock at the bottom, and on top, capping it off, is impermeable rock. Well, I'm sure there's many places where that sort of geology exists on the moon, albeit for different reasons. If you can find those formations and drill underneath them, you can see either any of those resources, any of those lighter elements underground that are accessible in such quantities as to make the whole process worthwhile. And that's really the rub there, is not whether you can extract a few atoms of hydrogen or helium or whatever from this well, but is it going to be in useful amounts sufficient to make it worthwhile to drill for them? And we don't know the answer to that because we haven't done it. That's what I addressed in my last video, which is exploration for resources, and also to along piggybacked on top of that is also exploration for scientific reasons. So resources on the moon. There's another resource of sorts that exists on the moon in abundance, which doesn't exist as much on places like Mars or the asteroid belt or the outer solar system, and that is energy in the form of sunlight. There's one problem with that, though. The night on the moon is 14 days long, so that's a significant issue for solar power. There are ways, however, to get around that. One way is to simply have, a stretch of solar power stations going right around the planet, so that some of them are going to be active at some point. And that's probably a more difficult way of doing it. Another way of doing it would be to have mirrors in space, a series of mirrors of space that, as let's say this is the light side of the moon, this is the dark side of the moon. The satellites come around, and while they're still in the light, but they can beam sunlight to a collector on the nighttime side, and so that one goes around. It's blocked temporarily by the sun, and comes around this way and can beam energy again, and you have another one coming up behind it. So if you have a series of large space mirrors, you can use those space mirrors to ensure a continuous supply of sunlight to a base of some sort on the moon. But it does have the access to sunlight. It's just that the nights are kind of long. And that's something that's pretty important, because there's going to be a lot of, it's something I'll deal in a later episode, a lot of processes for extracting raw materials that may be really energy intensive. For instance, getting slightly away from our point here, for instance, there's asteroids, C-class asteroids, which are basically just undifferentiated star stuff, just undifferentiated material from the beginning of the solar system, right? And pretty much anything that you want is in there. It's in there somewhere, right? Problem is, it's just totally. Well, it's not totally homogeneous, but it's very homogeneous. There's no ores of anything except for obviously in the nickel iron meteorites. Those are almost solid nickel iron and olivine or whatever. But for the C-class asteroids, even though they're chock full of raw materials, especially those lighter raw materials that the moon lacks, it's all sort of evenly distributed through the matrix, right? One process for getting some of that stuff out, and we're kind of treading on one of our next episodes, is to simply melt it, vaporize it at a high temperature, and through various ways separating that plasma out into its fundamental elements, right? Well, doing that would take a lot of energy, which if you're in the inner solar system, not that big of a problem. We got lots of solar energy. In the outer solar system, that's a bit of a problem. And that's coming around to another resource or asset that the moon has, which is it's a very good staging area. It doesn't take that much energy to start a mission to the outer solar system or to the asteroids from the moon, or to bring those resources back to the moon. It's an excellent staging area. It doesn't have a wide variety of resources. It does have resources. So, again, the primary asset of the moon is location. It's just in a great, as far as colonization efforts go, it's just in a great place. There are still things that have to be overcome, even if we can get resources coming in from the asteroids to the moon. There's still other issues, but that's the primary benefit of the moon. That's its location, and we should be spending a lot more time focusing on the moon than some of the places we are focusing on. From a scientific point of view, there's no question that exploring Mars is more important than exploring the moon, from a scientific point of view. From a colonization point of view, there's no question that exploring the moon is more important. From the point of view of the science that can be done there's no question the Mars wins hands down. Simply the possibility that there could have been life there at some point almost would be a scientific matter of such weight that it almost outweighs any other scientific thing we could do in space. But as far as colonization goes, Mars has a lot of limitations. The moon has got a great location. It's a great place to bring materials from elsewhere in the solar system as a sort of a staging point. We should be spending a lot more time and money exploring the moon than we do. And it's not that we don't have unanswered questions about the moon. I think President Obama said when he was talking about exploring the asteroids, a new initiative to explore the asteroids, which on the whole I agree with. He said, well, the moon, we've been there. Well, no, we really haven't been there. I mean, we've cherry-picked a few real easy spots. But in terms of the total picture of the kind of resources we could get there and what we could do with those resources, we haven't done shit. So, the moon. The moon is an important thing. It's got a great location. We should do more to explore it and find out what resources we can get there. That's all for this episode of Space Colonization with Bob. And until next time, hasta la vista. Adios.